So now we are looking at the example of calculating the period, which is in. Okay, let us look at the example. How long will it take equipment of 950,000 to depreciate to 311,296 at 20% per annum? At reducing balance depreciation. So the formula when it comes to reducing balance depreciation is A equals to P 1 minus interest I to the power of N. And now finding all these variables, these values would be A here at this point. How long will it take equipment of 950,000? That means it was 950,000, that initial amount, to depreciate to 311,296. So that is the accumulated amount, the final amount basically. So that means A is 311,296. P is the initial amount, and this is 950,000. I, to depreciate to 311,296 at 20%. I is equals to 20 over 100, which is equals to 0.2. Anything left? N is equals to unknown, because it is what we are looking for, because it is how long will it take, for how many years, what is the period. So let us start off by substituting. Therefore, A, which is 311, remember we are depreciating, so the final amount is less than the initial amount, 311,000. So about this, so it is 11,296 is equals to P, which is 950,000. 1, 2, 3 times 1 minus I, the interest rate per annum. Here it isn't specified how many times it is compounded. So since it is per annum, it is compounded once a year. Therefore, it is 0.2 is the interest over 1. Let's put this in brackets. Times N times 1. Because we are looking for N, we do not have N as yet. So basically at this point, what we can do is divide 950,000 on both sides. Therefore, it is 311,296 over 950,000 is equals to, specifically, 1 minus 0.2 to the power of N when simplified properly. Therefore, 311,296 over 950,000 is equal to 0,8 to the power of n. So now at this point, what we're going to be looking at is logarithms. Logarithms. So basically, as we're looking at logarithms are the exponent is equals to, when you add in your calculator, there's a form whereby it is like log, then there will be some sort of square here at the bottom and another square here. There's a certain function in your calculator which looks like this specifically. So there you would type in the base and the number. Explaining this further, the number is normally the one on this side, on the other side I mean, and then the base, the exponent, there's like the exponent, and the base is like the number which the exponent is at. So basically there's a number and then there's a certain exponent to that number, and this is the number which is on the other side. Okay, this is sort of hard to explain, but here's an example right here. The exponent is n and the base is 0,8, and this here on the other side is the number. So now when trying to find n using logarithms, n is the exponent, right? So n comes down here. Then logarithm, using these types of logarithms, the base is this number here, which is the base, and the number which was on the other end becomes the number here. That's how you find n. Therefore, n is equal to log the base log, oh yeah, it is right here, base. The base was 0,8. Let's put that in brackets. Please also don't forget brackets even if it comes to logarithms. And the number here on the other side, which is the number, is this one right here. It is 311,296 over 950,000, all in brackets. So basically, if you look at it, this form right here, this form represents this form. As you can see, the exponent is n, which was right here, and then log base was 0,8 as it is here. The exponent as it is came here when including the logarithms, and then the number was the one on the left hand side, which doesn't necessarily have to be on the left hand side, is the number is equal to on the other hand, which was 311,296 over 950,000. So clearly this is gonna give you a rather great decimal, so it is rounded off to the mainly two decimals, but since, okay, let us round it off to 2 decimal first. At this point it was just equals to 5, therefore it is 5 years. answering to the question, how long will it take for the equipment worth 950,000 to depreciate to 311,296 at 20% per annum? It is 5 years.